Question 1. What factors determine the scope and depth of an impact assessment for a VMware Cloud Foundation deployment, considering its potential effects on existing IT infrastructure, operational workflows, and regulatory compliance obligations? Option A. The criticality of business applications, the sensitivity of data handled by those applications, the complexity of existing operational processes, and the specific regulatory frameworks governing the organization's industry and data types. Option B. The number of servers available for migration and the perceived ease of integrating new hardware with the VCF environment. Option C. The immediate cost savings projected from consolidating infrastructure and the perceived technical novelty of VMware Cloud Foundation. Option D. The availability of vendor-provided documentation and the general understanding of cloud computing principles within the IT department. The correct answer is A. The criticality of business applications, the sensitivity of data handled by those applications, the complexity of existing operational processes, and the specific regulatory frameworks governing the organization's industry and data types. Explanation. The scenario of deploying VMware Cloud Foundation, VCF, involves significant changes to an organization's IT infrastructure, impacting various business processes and potentially sensitive data. A thorough impact assessment is crucial to identify and mitigate risks before and during deployment. This assessment is not merely a technical exercise, but a strategic one, requiring collaboration across IT, security, compliance, and business units. The challenge lies in accurately forecasting the downstream effects of VCF implementation on existing applications, workflows, security postures, and regulatory adherence. The correct approach, focusing on a comprehensive analysis of technical, operational, security, and compliance implications, represents best professional practice because it aligns with the principles of responsible IT deployment and risk management. It ensures that potential disruptions are identified early, allowing for proactive mitigation strategies. This approach directly supports the adherence to established IT governance frameworks and internal policies that mandate due diligence in technology adoption. By systematically evaluating the impact on all relevant areas, it minimizes the likelihood of unforeseen issues, security breaches, or compliance violations post-deployment, thereby safeguarding business continuity and data integrity. An incorrect approach that prioritizes only the technical aspects of VCF deployment, neglecting operational workflows and security controls, is professionally unacceptable. This failure stems from a narrow, siloed perspective that overlooks critical interdependencies. Such an approach risks introducing vulnerabilities that could lead to data breaches, service disruptions, or non-compliance with data protection regulations, such as those governing the handling of personally identifiable information or financial data. Another incorrect approach that solely considers the immediate cost savings of VCF, without a commensurate evaluation of its long-term operational and security costs, is also professionally flawed. This oversight can lead to underestimation of resource requirements for ongoing management, security patching, and potential future integration challenges. It may also result in a failure to meet service-level agreements, SLAs, or compliance mandates that require specific security investments or operational resilience, potentially leading to regulatory penalties or reputational damage. A third incorrect approach that focuses exclusively on meeting the minimum technical requirements for VCF deployment, without considering the broader business context and user impact, is professionally deficient. This can lead to a solution that is technically sound but operationally impractical or detrimental to user productivity, ultimately undermining the intended benefits of the VCF adoption. It fails to recognize that technology deployment is a means to an end, supporting business objectives, and not an end in itself. The professional decision-making process for similar situations should involve a structured, multidisciplinary impact assessment. This process begins with clearly defining the scope and objectives of the VCF deployment. It then proceeds to identify all stakeholders and their respective concerns. A systematic evaluation of technical, operational, security, and compliance impacts should be conducted, utilizing checklists, workshops, and interviews. Risk identification and mitigation planning are integral steps, followed by the development of a comprehensive deployment and rollback strategy. Continuous monitoring and post-deployment review are essential to ensure the VCF environment meets its intended goals and remains compliant and secure. Question 2. Stakeholder feedback indicates a strong desire to accelerate the deployment timeline for a new VMware Cloud Foundation environment, with some teams pushing to bypass certain pre-deployment validation checks to expedite the initial setup of core services. They argue that these checks are time-consuming and that the environment can be stabilized post-deployment. What is the most appropriate course of action for the deployment specialist? Option A. Proceed with the deployment of core services as requested by stakeholders, prioritizing speed over the validation checks, with a plan to address any identified issues in a subsequent phase. Option B. Deploy the environment using a simplified configuration that omits advanced features and some validation steps, focusing only on the immediate needs of the requesting stakeholders. Option C. Adhere strictly to the VMware Cloud Foundation Deployment Guide, ensuring all pre-deployment validation checks are completed successfully before proceeding with the core services deployment, and communicate the importance of these steps to stakeholders. Option D. Implement a modified deployment sequence that skips only the least critical validation checks, as determined by the deployment specialist, to achieve a moderate acceleration of the timeline. The correct answer is C. Adhere strictly to the VMware Cloud Foundation Deployment Guide, ensuring all pre-deployment validation checks are completed successfully before proceeding with the core services deployment, and communicate the importance of these steps to stakeholders. Explanation. Scenario analysis. This scenario presents a common challenge in cloud deployments where differing stakeholder priorities can lead to conflicting requirements. The challenge lies in balancing immediate business needs for rapid deployment with the long-term operational stability and security mandated by VMware's best practices, and by extension, the implicit regulatory compliance expected in a professional deployment context. Failure to address these conflicts systematically can result in technical debt, security vulnerabilities, and ultimately, non-compliance with operational standards. Correct approach analysis. The correct approach prioritizes a structured, phased deployment that aligns with VMware Cloud Foundation, VCF, architectural principles and deployment guides. This involves thorough planning, validation of prerequisites, and adherence to the recommended sequence of operations. This methodology ensures that the foundation is built correctly, minimizing the risk of misconfigurations that could lead to instability or security gaps. This aligns with the professional responsibility to deploy solutions in a manner that is robust, secure, and maintainable, reflecting the implicit expectation of compliance with industry best practices and vendor guidelines, which are critical for any regulated environment. Incorrect approaches analysis. An approach that bypasses critical validation steps and proceeds with deployment based solely on stakeholder urgency risks, introducing significant instability and security vulnerabilities. This is professionally unacceptable as it deviates from established best practices for VCF deployment, potentially leading to a non-compliant and unsupportable environment. From a regulatory perspective, deploying a system with known or potential security flaws or operational deficiencies could be seen as a failure to exercise due diligence, especially if the deployed environment is intended for sensitive data or critical operations. Another incorrect approach might involve prioritizing a single stakeholder's immediate, albeit potentially short-sighted, request over the overall architectural integrity of the VCF deployment. This can lead to a fragmented or improperly configured environment, making future updates, management, and troubleshooting exceedingly difficult. Ethically, this demonstrates a lack of commitment to delivering a complete and robust solution, potentially compromising the long-term success and security of the project for all stakeholders. Finally, an approach that relies on ad hoc modifications or undocumented changes during deployment, driven by perceived expediency, is highly problematic. Such actions introduce significant risks of operational instability and security breaches. This is a direct contravention of professional deployment standards, which emphasize documentation, repeatability, and adherence to approved configurations. In a regulated context, undocumented changes can be a major compliance failure, as they make auditing and incident response extremely challenging. Professional reasoning. Professionals tasked with VCF deployments must adopt a decision-making framework that prioritizes adherence to vendor best practices and architectural integrity. This involves 1. Thoroughly understanding the VCF deployment lifecycle and prerequisites. 2. engaging all stakeholders to gather requirements but clearly communicating the technical constraints and recommended deployment order. 3. Implementing a phased approach with clear validation gates at each stage. 4. Documenting all decisions and configurations. 5. Escalating any significant deviations or conflicts to a decision-making body that can assess the risks against the potential benefits, ensuring that any approved deviations are thoroughly understood and mitigated. This systematic approach ensures a compliant, secure, and stable deployment. Question 3. The evaluation methodology shows that during a VMware Cloud Foundation deployment, several distinct approaches to integrating the management domain with existing network infrastructure were considered. Which approach best aligns with the principles of a secure, stable, and manageable VCF deployment? Option A. Extending the existing flat production network to encompass the VCF management domain, allowing all management components to communicate freely with production workloads to simplify initial setup. Option B. Deploying the VCF management domain on a network segment that has not been validated for compatibility with VCF, relying on the assumption that most standard Ethernet configurations will function adequately. Option C. Implementing the VCF management domain using a dedicated, isolated network segment with strict firewall rules, ensuring that only necessary management traffic can traverse to other network segments, and validating all network configurations against VMware's documented best practices for VCF networking. Option D. Utilizing a shared network infrastructure with the VCF workload domains for the management domain, assuming that the inherent security of VCF will protect the management components from potential workload domain issues. The correct answer is C. Implementing the VCF management domain using a dedicated, isolated network segment with strict firewall rules, ensuring that only necessary management traffic can traverse to other network segments, and validating all network configurations against VMware's documented best practices for VCF networking. Explanation. The evaluation methodology shows a critical need to understand the nuances of VMware Cloud Foundation, VCF deployment within a specific regulatory context, which for this exam is assumed to be a general IT deployment scenario without specific jurisdictional mandates beyond standard IT best practices and vendor guidelines. The professional challenge lies in balancing the technical requirements of VCF deployment with the operational and security considerations that impact long-term stability and compliance. This scenario requires careful judgment because a misstep in initial configuration or integration can lead to significant rework, security vulnerabilities, or performance degradation, all of which have direct implications for the business's ability to operate effectively and securely. The correct approach represents best professional practice because it prioritizes a systematic, phased deployment that aligns with VMware's recommended architecture and operational best practices. This includes thorough planning, validation of prerequisites, and a staged rollout of components. This methodology ensures that each layer of VCF is correctly implemented and integrated before proceeding, minimizing the risk of cascading failures. It also allows for early detection of issues and facilitates troubleshooting, leading to a more robust and secure deployment. Adhering to VMware's official documentation and release notes is paramount, as these resources contain the most up-to-date information on supported configurations, known issues, and deployment procedures, which are essential for a successful and compliant deployment. Incorrect approaches are professionally unacceptable due to specific failures in adhering to established IT deployment principles and vendor guidance. One incorrect approach might involve a lift and shift of existing infrastructure components without proper validation against VCF compatibility matrices. This fails to account for potential integration conflicts and can lead to instability, violating the principle of deploying within supported configurations. Another incorrect approach could be skipping critical pre-deployment checks, such as network readiness or storage validation. This directly contravenes best practices for infrastructure deployment, increasing the likelihood of encountering showstopper issues during or after deployment, which can have significant operational and financial consequences. A third incorrect approach might be to deviate from documented deployment sequences without a clear understanding of the interdependencies between VCF components. This can result in misconfigurations that are difficult to diagnose and rectify, potentially compromising the security posture and operational integrity of the cloud foundation. The professional reasoning process for similar situations should involve a deep understanding of the technology being deployed, a commitment to following vendor-recommended procedures, and a rigorous approach to validation at each stage. Professionals should always consult official documentation, leverage pre-deployment checklists, and conduct thorough testing in a non-production environment where possible. When faced with deviations or unique requirements, a risk assessment should be performed, and any proposed changes should be thoroughly documented and approved through a change management process. The ultimate goal is to achieve a stable, secure, and performant deployment that meets the business's objectives while adhering to industry best practices. Question 4. Investigation of a new VMware Cloud Foundation deployment reveals that the implementation team is considering placing all core management components, including vCenter Server, NSX Manager, and SDDC Manager, onto a single, flat network segment within the management domain to expedite the initial setup process. What is the most appropriate course of action to ensure a secure and compliant deployment? Option A. Deploy with the flat network and rely solely on host-based firewalls for security between management components. Option B. Deploy with the flat network and implement manual firewall rules at the physical network edge to segment management traffic. Option C. Proceed with the single, flat network segment for rapid deployment and plan to implement segmentation later. Option D. Immediately halt the deployment and re-architect the network to create distinct NSXT logical segments for each management component before proceeding. Correct answer is C. Proceed with the single, flat network segment for rapid deployment and plan to implement segmentation later. Explanation. Scenario analysis. This scenario presents a common implementation challenge in VMware Cloud Foundation, VCF, deployments, ensuring network segmentation and security compliance during the initial setup of the management domain. The challenge lies in balancing the need for rapid deployment with the imperative to adhere to strict security policies that dictate network isolation for different functional components. Failure to properly segment the network can lead to security vulnerabilities, compliance violations, and operational complexities. The pressure to deliver a functional environment quickly can tempt teams to take shortcuts, making careful judgment and adherence to best practices critical. Correct approach analysis. The correct approach involves leveraging VCF's built-in network segmentation capabilities, specifically by configuring distinct NSXT segments for different management components, e.g., vCenter Server, NSX Manager, SDDC Manager. This aligns with the principle of least privilege and defense in depth, which are fundamental to modern security frameworks and are implicitly expected in enterprise deployments. By isolating these components, the risk of lateral movement by potential attackers is significantly reduced. Furthermore, this approach ensures that the deployment adheres to common security best practices and regulatory expectations for secure infrastructure, even if specific regulations are not explicitly cited in the exam context, as secure design is a universal professional standard. This method also facilitates easier troubleshooting and management of network traffic. Incorrect approach is analysis. One incorrect approach is to place all management domain components on a single, flat network segment. This is a significant security failure as it eliminates network-based isolation, making all components vulnerable to any compromise within that segment. It directly violates the principle of least privilege and creates a wide attack surface. From a professional standpoint, this demonstrates a lack of understanding of fundamental network security principles and would likely lead to compliance issues in any regulated environment. Another incorrect approach is to manually configure firewall rules between components on the same segment without leveraging NSXT's logical segmentation. While attempting to add a layer of security, this is inefficient, prone to misconfiguration, and does not provide the robust isolation that logical segmentation offers. It also bypasses VCF's intended operational model, leading to potential conflicts and making future updates or troubleshooting more difficult. This approach is professionally unsound as it introduces unnecessary complexity and risk by not utilizing the platform's design capabilities. A third incorrect approach is to delay network segmentation until after the initial deployment is complete, opting for a quick, unsegmented deployment first. This is a critical security and compliance risk. The management domain is the foundation of the entire VCF environment. Compromising it can have cascading effects. Delaying segmentation means the environment is exposed to unnecessary risks during its most vulnerable initial phase. Professionally, this is a failure to prioritize security and risk management, which are paramount in any infrastructure deployment. Professional reasoning. Professionals should approach VCF deployments by prioritizing security and compliance from the outset. The decision-making process should involve a thorough understanding of the VCF architecture and its networking capabilities, particularly NSXT, before commencing deployment. A network design that incorporates logical segmentation for all components, especially the management domain, should be finalized and validated against security policies. This proactive approach ensures that security is built in, not bolted on. When faced with time pressures, professionals must resist the temptation to bypass essential security configurations. Instead, they should communicate the risks associated with shortcuts and advocate for the necessary time to implement a secure and compliant design. This involves understanding the potential consequences of non-compliance and security breaches, and making informed decisions that align with professional responsibility and organizational risk tolerance. Question 5. What factors determine the most effective strategy for deploying VMware Cloud Foundation in a production environment, considering security, operational stability, and adherence to best practices? Option A. The adoption of custom configurations to meet unique infrastructure requirements, even if they deviate significantly from VMware's recommended architecture. Option B. The speed at which the deployment can be completed to meet immediate business needs, with post-deployment adjustments made as required. Option C. The thoroughness of the pre-deployment planning, the adherence to VMware's validated design principles, and the implementation of a phased validation process throughout the deployment lifecycle. Option D. The utilization of the most recent available software versions without extensive pre-deployment testing, assuming vendor updates address all potential issues. The correct answer is C. The thoroughness of the pre-deployment planning, the adherence to VMware's validated design principles, and the implementation of a phased validation process throughout the deployment lifecycle. Explanation. The scenario involves deploying VMware Cloud Foundation, VCF, in a regulated environment, specifically within the context of the 5V0-3123 exam's implied jurisdiction, which is assumed to be a general IT professional context without specific national regulatory mandates unless otherwise stated, focusing on best practices and vendor guidelines. The professional challenge lies in balancing the technical requirements of a VCF deployment with the need for robust security, compliance, and operational integrity. This requires a deep understanding of VCF architecture, its integration points, and the potential impact of configuration choices on the overall security posture and adherence to operational best practices. Careful judgment is essential to avoid introducing vulnerabilities or operational inefficiencies. The correct approach emphasizes a phased, documented, and validated deployment strategy that aligns with VCF best practices and security principles. This includes thorough planning, adherence to VMware's recommended configurations, and rigorous testing at each stage. This approach represents best professional practice because it minimizes risk, ensures a stable and secure deployment, and facilitates future troubleshooting and upgrades. It aligns with the implicit regulatory and ethical obligation to deploy systems that are secure, reliable, and maintainable, thereby protecting the organization's data and operations. Incorrect approaches fail by either oversimplifying the deployment process, neglecting critical security considerations, or deviating from established best practices without proper justification. One incorrect approach might involve prioritizing speed over thoroughness, leading to potential misconfigurations that could introduce security gaps or operational instability. This is professionally unacceptable as it violates the duty of care to deploy systems that are fit for purpose and secure. Another incorrect approach could be to bypass essential validation steps, assuming default settings are sufficient. This is a failure to exercise due diligence and could result in a deployment that is non-compliant with security policies or prone to failure. A third incorrect approach might involve implementing custom configurations without a clear understanding of their impact on VCF's core functionality or security, potentially leading to unsupported states and increased complexity. This demonstrates a lack of understanding of the VCF ecosystem and a disregard for established architectural principles. A professional decision-making process for similar situations should involve a structured approach. 1. Understand the specific requirements and constraints of the environment, including any compliance mandates. 2. Consult VMware's official documentation and best practices for VCF deployment. 3. Develop a detailed deployment plan that includes all necessary steps, security considerations, and validation procedures. 4. Execute the plan methodically, performing validation checks at each stage. 5. Document all configurations and decisions made. 6. Conduct comprehensive testing of the deployed environment before going live. 7. Establish ongoing monitoring and maintenance procedures. Question 6. When evaluating a request from a specific business unit for a custom network configuration within a VMware Cloud Foundation environment that deviates from the standard network segmentation and firewall rules, what is the most professional and compliant approach to ensure both the business unit's needs are met and the integrity of the VCF infrastructure is maintained? Option A. Conduct a detailed technical assessment of the requested network configuration. Evaluate its impact on existing VCF security policies and operational procedures, and propose a solution that aligns with architectural best practices and compliance requirements, potentially involving a phased implementation or a dedicated network segment if necessary. Option B. Immediately implement the requested custom network configuration as specified by the business unit, assuming their understanding of their application's needs is sufficient and that any potential conflicts will be resolved post-deployment. Option C. Grant the business unit elevated administrative privileges to modify the VCF network configuration directly, allowing them to implement their desired changes without further oversight. Option D. Inform the business unit that their request cannot be accommodated due to the rigid nature of the VCF network architecture, and suggest they explore alternative solutions outside of the managed VCF environment. The correct answer is A. Conduct a detailed technical assessment of the requested network configuration, evaluate its impact on existing VCF security policies and operational procedures, and propose a solution that aligns with architectural best practices and compliance requirements, potentially involving a phased implementation or a dedicated network segment if necessary. Explanation. The scenario presents a common challenge in VMware Cloud Foundation deployments, balancing the immediate needs of a business unit with the long-term strategic goals and operational stability of the entire cloud environment. The challenge lies in the potential for a single department's urgent request to introduce complexity, security risks, or performance degradation that impacts other users or the overall health of the VCF infrastructure. This requires careful judgment to ensure that solutions are not only functional for the requesting stakeholder, but also compliant with established architectural principles, security policies, and operational best practices, all within the context of the 5V0-31. 23 exams implied regulatory and compliance framework for enterprise cloud deployments. The correct approach prioritizes a thorough understanding of the business unit's requirements and then meticulously maps those requirements to the existing VCF architecture and its defined operational procedures. This involves engaging in detailed technical discussions, assessing the impact on the broader VCF environment, and ensuring that any proposed solution adheres to security baselines, performance SLAs, and the principle of least privilege. This approach represents best professional practice because it proactively mitigates risks, ensures scalability, and maintains the integrity of the VCF deployment. It aligns with the professional responsibility to deliver solutions that are not only effective, but also sustainable and secure, reflecting a commitment to the overall health and compliance of the IT infrastructure. An incorrect approach that focuses solely on the immediate technical feasibility without considering the broader implications is professionally unacceptable. This could lead to the introduction of shadow IT, security vulnerabilities, or performance bottlenecks that are difficult to manage and remediate later. Such an approach fails to uphold the professional duty to ensure the stability and security of the enterprise cloud environment. Another incorrect approach that bypasses established change management processes or security reviews introduces significant compliance risks. This can violate internal policies and potentially external regulatory requirements related to data security, access control, and auditability, leading to potential breaches or noncompliance penalties. The professional decision-making process for similar situations should involve a structured approach. First, clearly define and document the stakeholders' requirements. Second, assess the impact of these requirements on the existing VCF architecture, security posture, and operational procedures. Third, identify potential solutions that align with VCF best practices and organizational policies. Fourth, conduct a risk assessment for each proposed solution, considering security, performance, scalability, and compliance. Fifth, engage in collaborative discussions with relevant teams, e.g., security operations architecture, to validate the chosen approach. Finally, ensure all changes are implemented through a formal change management process with appropriate testing and validation. Question 7. The monitoring system demonstrates a significant increase in latency for critical applications hosted within the VMware Cloud Foundation environment. Network traffic analysis shows no unusual spikes, and CPU and memory utilization on the ESXi hosts appear within normal parameters. What is the most effective initial step to diagnose the root cause of this performance degradation? Option A. Dispatch a hardware technician to inspect the physical network switches and storage arrays. Option B. Review vCenter server performance metrics and NSXT logical switch/router statistics for anomalies. Option C. Immediately initiate a reboot of all affected ESXi hosts to clear potential transient issues. Option D. Focus troubleshooting efforts solely on the individual application logs for error messages. The correct answer is B. Review vCenter server performance metrics and NSXT logical switch/router statistics for anomalies. Explanation: scenario analysis. This scenario presents a common challenge in cloud deployments where unexpected performance degradation impacts critical services. The professional challenge lies in accurately diagnosing the root cause of the performance issue within a complex, multi-layered VMware Cloud Foundation environment. Misidentification of the problem can lead to wasted resources, extended downtime, and potential noncompliance with service-level agreements, SLAs, which are often governed by contractual obligations and industry best practices. The urgency of resolving the issue while maintaining system integrity and data security necessitates a systematic and informed approach. Correct approach analysis. The correct approach involves leveraging the integrated monitoring and logging capabilities of VMware Cloud Foundation to pinpoint the specific component or service experiencing the bottleneck. This aligns with best professional practices for incident response and troubleshooting in virtualized environments. By examining vCenter server performance metrics, NSXT network flow data, and SDDC manager logs, a technician can systematically isolate the issue to a particular layer, e.g., compute, network, storage, or even a specific workload. This methodical approach ensures that remediation efforts are targeted and effective, minimizing disruption and adhering to the principles of efficient resource management and operational stability, which are implicitly expected in professional IT operations. Incorrect approach is analysis. One incorrect approach is to immediately assume a hardware failure at the physical infrastructure level without first exhausting the diagnostic capabilities within the VCF software stack. This is professionally unsound because it bypasses the layered troubleshooting methodology inherent in VCF, potentially leading to unnecessary hardware interventions, increased downtime, and significant cost. It also fails to consider that performance issues are often software or configuration-related. Another incorrect approach is to focus solely on individual virtual machine performance without correlating it to the underlying VCF infrastructure. While VM performance is important, a VCF-level issue could manifest as degraded performance across multiple VMs. Ignoring the broader VCF context means missing the systemic root cause, leading to ineffective troubleshooting and prolonged service impact. This approach lacks the holistic perspective required for managing a complex cloud platform. A third incorrect approach is to restart services randomly without a clear hypothesis or understanding of the potential impact. This is a highly risky and unprofessional method that can exacerbate the problem, cause data corruption, or lead to unexpected service outages. It demonstrates a lack of systematic problem-solving and a disregard for the potential consequences of uncontrolled actions within a production environment. Professional reasoning. Professionals should adopt a structured incident response framework. This typically involves 1. Identification, recognizing the symptoms of the problem. 2. Containment, taking immediate steps to limit the impact. 3. Diagnosis, systematically investigating the root cause using available tools and logs. 4. Resolution, implementing a fix. 5. Recovery, verifying the fix and restoring full service. 6. Post-incident review, analyzing the event to prevent recurrence. In this scenario, the diagnostic phase is critical, requiring the use of VCF's built-in tools to understand the performance bottleneck within its intended operational context. Question 8. Process analysis reveals that a critical VMware Cloud Foundation deployment is underway. Which of the following approaches best addresses the inherent risks associated with integrating compute, storage, networking, and management layers within this complex environment? Option A. Rely exclusively on the default security configurations provided by VMware for all VCF components, assuming these settings are sufficient for the organization's risk profile. Option B. Defer all significant risk assessment activities until after the VCF environment has been fully deployed and is operational. Option C. Conduct a comprehensive risk assessment that identifies potential threats and vulnerabilities across all VCF components, evaluates their likelihood and impact, and prioritizes them for mitigation, aligning with cybersecurity best practices and relevant regulatory guidelines. Option D. Limit the risk assessment to only the initial deployment of the core VCF management components, excluding risks associated with integrated workloads and ongoing operational changes. The correct answer is C. Conduct a comprehensive risk assessment that identifies potential threats and vulnerabilities across all VCF components, evaluates their likelihood and impact, and prioritizes them for mitigation, aligning with cybersecurity best practices and relevant regulatory guidelines. Explanation. Scenario analysis. Deploying VMware Cloud Foundation, VCF, involves integrating multiple complex components, including compute, storage, networking, and management layers. A key challenge in this process is identifying and assessing the potential risks associated with each deployment phase and the overall VCF architecture. Failure to conduct a thorough risk assessment can lead to security vulnerabilities, operational disruptions, compliance issues, and significant financial losses. The professional challenge lies in proactively identifying these risks, understanding their potential impact, and developing effective mitigation strategies within the constraints of the specific regulatory framework governing the deployment. Correct approach analysis. The correct approach involves a systematic and comprehensive risk assessment that aligns with established cybersecurity best practices and any applicable regulatory guidelines for the deployment environment. This includes identifying potential threats and vulnerabilities across all VCF components, evaluating the likelihood and impact of these risks, and prioritizing them for mitigation. This approach ensures that security and operational considerations are embedded from the outset, aligning with the principle of security by design. It also supports the organization's compliance obligations by demonstrating due diligence in managing potential risks, which is a fundamental requirement in most regulatory frameworks for IT deployments. Incorrect approaches analysis. One incorrect approach is to solely rely on vendor default configurations and security settings without performing an independent risk assessment. This fails to account for the specific threat landscape and operational context of the organization, potentially leaving critical vulnerabilities unaddressed. This approach is ethically questionable as it abdicates responsibility for due diligence and can lead to non-compliance with regulatory mandates that require organizations to understand and manage their own risks. Another incorrect approach is to defer all risk assessment activities to the post-deployment phase. This is a reactive rather than proactive stance. It significantly increases the likelihood of security breaches or operational failures occurring during or immediately after deployment, which can be far more costly and damaging to remediate. From a regulatory perspective, this demonstrates a lack of foresight and can be interpreted as a failure to implement appropriate risk management controls, potentially leading to penalties. A third incorrect approach is to focus the risk assessment only on the initial deployment of core VCF components, neglecting the ongoing operational risks and the risks associated with future updates and integrations. VCF is a dynamic environment, and risks evolve. A limited scope assessment fails to provide a holistic view of the risk posture, leaving the organization exposed to emerging threats and vulnerabilities over the lifecycle of the VCF deployment. This can violate regulatory requirements that mandate continuous risk monitoring and management. Professional reasoning. professionals should adopt a proactive and comprehensive risk management framework. This involves integrating risk assessment into every stage of the VCF deployment lifecycle, from planning and design through to operation and decommissioning. The process should involve cross-functional teams, including security, operations, and compliance personnel. When faced with a deployment scenario, the professional should first identify the scope of the assessment, then systematically identify potential risks, analyze their likelihood and impact, and finally develop and implement appropriate mitigation strategies. This structured approach ensures that risks are managed effectively and in alignment with regulatory expectations and ethical responsibilities. Question 9. Risk assessment procedures indicate that a newly deployed VMware Cloud Foundation environment, intended to host sensitive financial data, has a potential vulnerability in the configuration of its NSXT data center microsegmentation policies, which could allow unauthorized lateral movement between workload domains. What is the most appropriate next step in the risk management process for this specific scenario? Option A. Immediately review and reconfigure NSXT microsegmentation policies to enforce least privilege access between workload domains, prioritizing the protection of sensitive financial data. Option B. Focus on strengthening perimeter firewall rules for the VCF environment, as this is the primary defense against external threats. Option C. Defer any immediate action on NSXT configuration until a comprehensive security audit of the entire VCF deployment is completed. Option D. Document the potential vulnerability and schedule a review of the NSXT configuration during the next routine operational maintenance window. The correct answer is A. Immediately review and reconfigure NSXT microsegmentation policies to enforce least privilege access between workload domains, prioritizing the protection of sensitive financial data. Explanation. The scenario presents a common challenge in VMware Cloud Foundation deployments, balancing the need for robust security and compliance with operational efficiency and cost. The challenge lies in identifying and prioritizing risks that are both significant and actionable within the context of the specific deployment and its regulatory environment. A deep understanding of the VMware Cloud Foundation architecture, its components, and their interdependencies is crucial for accurate risk identification. Furthermore, knowledge of relevant regulatory frameworks is essential to ensure that the risk assessment aligns with compliance obligations. The correct approach represents best professional practice because it systematically identifies potential threats and vulnerabilities across the entire VCF stack, from the foundational infrastructure to the deployed workloads. It then prioritizes these risks based on their potential impact and likelihood, allowing for the allocation of resources to mitigate the most critical issues first. This aligns with the principles of proactive risk management, which is a cornerstone of secure and compliant IT operations. By focusing on specific VCF components and their associated risks, such as data protection for management domain components or access control for workload domains, the assessment directly addresses the unique security posture of the VCF environment. This methodical approach ensures that the deployment meets its security objectives and adheres to any applicable regulatory requirements without unnecessary over-engineering or overlooking critical vulnerabilities. An incorrect approach that focuses solely on network security without considering the broader VCF architecture would be professionally unacceptable. This failure stems from an incomplete understanding of VCF's integrated nature, where risks can originate from or impact multiple layers beyond just the network. For instance, neglecting the security of the vCenter server or NSX manager within the management domain could expose the entire VCF environment to compromise, irrespective of network perimeter security. Another incorrect approach that prioritizes cost reduction over identified security risks would be a direct ethical and regulatory failure. This demonstrates a disregard for the potential consequences of security breaches, which can lead to data loss, service disruption, reputational damage, and significant financial penalties, especially if regulatory noncompliance is a factor. Such an approach prioritizes short-term financial gains over long-term stability and security, which is contrary to professional responsibility. The professional decision-making process for similar situations should involve a structured risk assessment methodology. This begins with clearly defining the scope of the VCF deployment and its operational context. Next, identify potential threats and vulnerabilities specific to each VCF component and its interactions. Evaluate the likelihood and potential impact of each identified risk, considering factors such as data sensitivity, business criticality, and regulatory requirements. Prioritize risks based on this evaluation, focusing on those with the highest potential impact and likelihood. Develop and implement appropriate mitigation strategies, which may include technical controls, policy changes, or procedural updates. Finally, establish a process for ongoing monitoring and review of risks and the effectiveness of mitigation measures. This iterative process ensures that the VCF deployment remains secure and compliant throughout its lifecycle. Question 10. Compliance review shows that a recent VMware Cloud Foundation deployment deviated from the documented and approved process optimization steps, leading to a temporary increase in deployment time for a specific component. The deployment team implemented a workaround to expedite the process without formally documenting the deviation or its resolution. Which of the following actions best addresses this situation? Option A. Escalate the issue to senior management, highlighting the deployment team's initiative in finding a solution, and request a review of the process optimization steps to determine if they are still relevant. Option B. Conduct a post-deployment technical review of the affected component to ensure its functionality and performance, and consider the deviation a one-time occurrence that does not require further process investigation. Option C. Initiate a formal root cause analysis of the process deviation, involving the deployment and operations teams, to identify the underlying reasons for the delay and implement corrective actions to prevent recurrence, while ensuring all changes are properly documented and validated. Option D. Immediately update the deployment documentation to reflect the workaround used, thereby formalizing the expedited process for future deployments. The correct answer is C. Initiate a formal root cause analysis of the process deviation, involving the deployment and operations teams, to identify the underlying reasons for the delay and implement corrective actions to prevent recurrence, while ensuring all changes are properly documented and validated. Explanation. This scenario presents a common challenge in cloud deployments, balancing the need for rapid deployment with the imperative of adhering to established operational processes and compliance requirements. The professional challenge lies in identifying the root cause of the deviation from the optimized deployment process and implementing a corrective action that not only resolves the immediate issue but also prevents recurrence, all while maintaining the integrity of the deployed VMware Cloud Foundation environment. The correct approach represents best professional practice because it directly addresses the identified process deviation through a structured, root cause analysis. This aligns with the principles of continuous improvement and operational excellence, which are implicitly mandated by the need to maintain a secure, stable, and compliant cloud infrastructure, as per VMware's best practices and the underlying regulatory frameworks governing cloud deployments. By involving the relevant stakeholders and documenting the findings and remediation, this approach ensures transparency, accountability, and knowledge sharing, fostering a culture of proactive problem-solving. An incorrect approach that bypasses established change control and validation procedures, even if it appears to resolve the immediate deployment issue, represents a significant regulatory and ethical failure. It undermines the auditability of the deployment process, increases the risk of introducing unintended vulnerabilities or misconfigurations, and violates the principle of least privilege and segregation of duties. Such an approach demonstrates a disregard for established governance and can lead to non-compliance with security standards and operational policies, potentially resulting in data breaches, service disruptions, and reputational damage. Another incorrect approach that focuses solely on the technical fix without investigating the process breakdown is also professionally unacceptable. While a technical solution might be necessary, ignoring the underlying process deficiency means the same issue is likely to recur. This failure to address the systemic cause is a dereliction of professional duty, as it does not contribute to long-term stability or efficiency and can lead to repeated firefighting rather than proactive management. The professional decision-making process for similar situations should involve a systematic approach. First, clearly define the observed deviation from the optimized process. Second, conduct a thorough root cause analysis involving all relevant technical and operational teams. Third, evaluate potential solutions, prioritizing those that address the root cause and align with established governance and compliance frameworks. Fourth, implement the chosen solution through the appropriate change management channels, ensuring proper documentation and validation. Finally, monitor the effectiveness of the implemented solution and update processes as necessary to prevent future occurrences. Question 11. Market research demonstrates a growing demand for advanced analytics services that require integration with sensitive customer data stored within the VMware Cloud Foundation. A proposal is put forth to rapidly deploy a new analytics platform, emphasizing speed to market and the immediate availability of these new services to end users. What is the most professionally responsible approach to ensure this deployment aligns with security and compliance mandates? Option A. Implement the new analytics platform using the latest features, assuming that newer technologies inherently possess stronger security and compliance capabilities. Option B. Conduct a comprehensive impact assessment that evaluates the effects on security controls, data privacy, operational stability, and regulatory compliance, involving relevant stakeholders and documenting all findings and mitigation strategies. Option C. Proceed with the deployment immediately to capitalize on market demand, relying on the vendor's default security configurations and assuming compliance with existing data privacy policies. Option D. Perform a quick technical review focusing solely on performance metrics and integration feasibility, deferring detailed security and compliance checks until after the initial launch. The correct answer is B. Conduct a comprehensive impact assessment that evaluates the effects on security controls, data privacy, operational stability, and regulatory compliance, involving relevant stakeholders and documenting all findings and mitigation strategies. Explanation. Scenario analysis. The scenario presents a common challenge in cloud deployments, balancing the desire for rapid innovation and feature deployment with the need for robust security and compliance. The pressure to deliver new services quickly can lead to overlooking critical impact assessment steps, potentially exposing the organization to regulatory noncompliance, security breaches, and operational instability. The professional challenge lies in advocating for and executing thorough impact assessments within a fast-paced development cycle, ensuring that the VMware Cloud Foundation deployment aligns with business objectives without compromising risk management. Correct approach analysis. The correct approach involves a comprehensive impact assessment that systematically evaluates the potential effects of the proposed changes on various aspects of the VMware Cloud Foundation environment. This includes assessing the impact on security controls, data privacy, operational stability, performance, and compliance with relevant regulations. By engaging stakeholders from security, compliance, operations, and business units, and by documenting findings and mitigation strategies, this approach ensures that risks are identified and addressed proactively. This aligns with best professional practices by prioritizing a risk-based methodology, which is a cornerstone of effective IT governance and compliance frameworks. It ensures that the deployment adheres to the principle of least privilege, maintains data integrity, and supports the organization's overall security posture, thereby preventing potential regulatory violations and operational disruptions. Incorrect approaches analysis. An approach that prioritizes immediate deployment without a formal impact assessment is professionally unacceptable. This bypasses critical risk identification and mitigation steps, directly violating the principles of responsible IT deployment and governance. It creates a high probability of introducing vulnerabilities that could lead to data breaches or unauthorized access, thus failing to meet security standards and potentially contravening data protection regulations. Another incorrect approach is to conduct a superficial assessment that only considers technical performance metrics while neglecting security and compliance implications. This is a significant regulatory and ethical failure because it ignores the broader context of the deployment. Modern regulatory frameworks, such as those governing data privacy and cloud security, mandate a holistic view of impact, encompassing not just functionality, but also the protection of sensitive information and adherence to legal obligations. Finally, an approach that relies solely on vendor documentation without internal validation or stakeholder consultation is also professionally unsound. While vendor documentation is valuable, it cannot fully account for an organization's specific security policies, risk appetite, or unique compliance requirements. This can lead to misconfigurations or the omission of necessary controls, resulting in non-compliance and security gaps. Professional reasoning. Professionals should adopt a structured, risk-aware decision-making process. This begins with understanding the proposed changes and their intended benefits. Next, a thorough impact assessment should be initiated, involving cross-functional teams to identify potential risks across security, compliance, operational, and business domains. The findings should be documented, and mitigation plans developed and approved by relevant stakeholders. Only after these steps are completed and risks are adequately managed should the deployment proceed. This iterative process ensures that deployments are not only technically sound, but also secure, compliant, and aligned with organizational objectives, fostering trust and minimizing potential liabilities. Question 12. The audit findings indicate a potential security misconfiguration in the network segmentation strategy during a recent VMware Cloud Foundation deployment that was not part of the approved design documentation. The deployment specialist has identified the specific area of concern and its potential implications for data isolation. What is the most professional and ethical course of action for the deployment specialist? Option A. Halt the entire deployment immediately and inform the client of a critical security flaw without further internal assessment. Option B. Independently implement a fix for the misconfiguration without informing the project team or client to expedite resolution. Option C. Immediately document the finding, assess its potential impact, and escalate it to the project manager and security team for collaborative review and decision-making. Option D. Proceed with the deployment as planned, assuming the risk is minimal, and address the misconfiguration in a future patch or update. The correct answer is C. Immediately document the finding, assess its potential impact, and escalate it to the project manager and security team for collaborative review and decision-making. Explanation. Scenario analysis. This scenario presents a professional challenge where a deployment specialist discovers a potential security vulnerability during a VMware Cloud Foundation deployment that was not explicitly documented in the approved design. The challenge lies in balancing the immediate need to meet project deadlines and client expectations with the ethical and professional responsibility to ensure the security and integrity of the deployed environment. Ignoring the finding could lead to significant security breaches, reputational damage, and potential regulatory noncompliance. Conversely, immediately halting the deployment without proper assessment and communication could cause significant project delays and financial implications for the client. Careful judgment is required to navigate these competing pressures. Correct approach analysis. The correct approach involves a systematic and transparent process. First, the specialist must thoroughly document the discovered vulnerability, its potential impact, and the technical details. This documentation is crucial for clear communication and for establishing a record of the finding. Second, the specialist must immediately escalate this finding to the appropriate stakeholders, including the project manager, security team, and potentially the client's technical lead. This escalation ensures that the issue is brought to the attention of those with the authority and expertise to make informed decisions. The goal is to collaboratively assess the risk, explore remediation options, and determine the best course of action, which might involve a design change, a mitigation strategy, or a controlled delay. This approach upholds professional integrity, prioritizes security, and fosters trust through open communication, aligning with best practices for responsible IT deployment and risk management. Incorrect approaches analysis. One incorrect approach is to ignore the vulnerability to avoid delaying the project. This is a direct violation of professional ethics and could lead to severe security breaches, data loss, and legal liabilities for both the specialist and the organization. It demonstrates a lack of due diligence and a disregard for the client's security posture. Another incorrect approach is to attempt to fix the vulnerability independently without proper authorization or assessment. While well-intentioned, this can introduce new, unforeseen issues, compromise the integrity of the deployment, and bypass established change control processes. It also undermines the collaborative decision-making process and the expertise of other team members or security professionals. A third incorrect approach is to immediately halt the deployment and inform the client of a critical failure without first conducting a preliminary assessment and developing potential solutions. While transparency is important, a premature halt without a clear understanding of the impact or proposed remediation can cause unnecessary panic and erode client confidence. A more measured approach involving internal assessment and solution proposal before client notification is generally preferred. Professional reasoning. Professionals should adopt a structured decision-making process when encountering unexpected issues during deployments. This process typically involves 1. Identification and documentation. Clearly identify and document the issue, its potential impact, and relevant technical details. 2. Assessment and analysis. Evaluate the severity and scope of the issue. 3. Escalation and communication. Inform relevant stakeholders promptly and transparently, providing all necessary information for informed decision-making. 4. Collaboration and solutioning. Work with stakeholders to explore and agree upon remediation strategies. 5. Implementation and verification. Implement the agreed-upon solution and verify its effectiveness. This framework ensures that issues are addressed systematically, ethically, and in a manner that protects the client's interests and maintains professional integrity. Question 13. The audit findings indicate that the impact assessment process for recent VMware Cloud Foundation updates has been inconsistent, leading to unexpected service disruptions. Which of the following approaches best addresses this issue to ensure future deployments and updates are managed effectively and compliantly? Option A. Focus the impact assessment primarily on the immediate technical configuration changes within the vCenter server and NSXT manager, assuming other components will adapt automatically. Option B. Rely on the experience of senior engineers to verbally assess the potential impact of updates based on their historical knowledge of similar deployments. Option C. Delegate the entire impact assessment process to the development team responsible for the application being deployed, as they are most familiar with its functional requirements. Option D. Implement a standardized impact assessment framework that requires detailed analysis of dependencies, potential performance degradation, security implications, and business continuity risks for all proposed changes to the VMware Cloud Foundation environment, with documented sign-offs from relevant stakeholders. The correct answer is D. Implement a standardized impact assessment framework that requires detailed analysis of dependencies, potential performance degradation, security implications, and business continuity risks for all proposed changes to the VMware Cloud Foundation environment, with documented sign-offs from relevant stakeholders. Explanation. The audit findings indicate a potential gap in the impact assessment process for a VMware Cloud Foundation deployment. This scenario is professionally challenging because a thorough impact assessment is crucial for understanding the downstream effects of changes, ensuring compliance with operational standards, and mitigating risks. The challenge lies in accurately identifying all affected components, services, and stakeholders, and then quantifying the potential consequences of any proposed modifications or incidents. The correct approach, which involves a comprehensive review of the existing VMware Cloud Foundation architecture, dependencies, and operational procedures, represents best professional practice. This aligns with the principles of robust IT governance and risk management, which are implicitly expected in a professional deployment specialist role. By systematically analyzing the potential impact on performance, availability, security, and business continuity, the specialist can proactively identify risks and develop appropriate mitigation strategies. This thoroughness ensures that decisions are data-driven and that the deployment adheres to established best practices and any relevant VMware guidelines for operational stability. An incorrect approach that focuses solely on the immediate technical changes without considering broader operational or business implications represents a significant regulatory and ethical failure. This oversight could lead to unforeseen disruptions, service degradation, or security vulnerabilities, potentially violating service-level agreements, SLAs, or internal operational policies. Another incorrect approach, which relies on anecdotal evidence or past experience without formal documentation or validation, is professionally unacceptable as it lacks the rigor required for auditable and repeatable processes. This can lead to inconsistent outcomes and a failure to meet compliance requirements. A third incorrect approach, which delegates the impact assessment to a single individual without cross-functional review, risks bias and incomplete analysis, failing to leverage the collective expertise necessary for a holistic understanding of the impact. Professionals should employ a structured decision-making process that begins with clearly defining the scope of the assessment. This involves identifying all relevant systems, applications, and services that could be affected by the change or incident. Next, They should gather information from various sources, including technical documentation, operational logs, and stakeholder input. The analysis phase should systematically evaluate the potential consequences across different dimensions, such as performance, security, availability, and cost. Finally, the findings should be documented, communicated to relevant parties, and used to inform decision-making regarding risk mitigation and change implementation. Question 14. The control framework reveals that while the current VMware Cloud Foundation deployment is operational, there are opportunities to streamline incident response times and reduce manual intervention in routine maintenance tasks. Considering the principles of process optimization, which of the following actions would best address these findings? Option A. Prioritize immediate cost-saving measures by reducing the frequency of monitoring alerts and deferring non-critical maintenance tasks. Option B. Implement automated health checks and self-healing capabilities for common issues, coupled with a structured review of incident logs to identify patterns for further automation. Option C. Introduce ad hoc scripting to address individual recurring incidents as they arise, without a formal process for validation or integration. Option D. Focus on documenting all existing manual processes in detail to ensure knowledge transfer without altering the current operational procedures. The correct answer is B. Implement automated health checks and self-healing capabilities for common issues, coupled with a structured review of incident logs to identify patterns for further automation. Explanation. This scenario presents a common challenge in cloud deployments where the initial design, while functional, may not align with evolving operational best practices and the need for continuous improvement. The professional challenge lies in balancing the immediate need for a stable environment with the long-term benefits of process optimization, particularly when faced with resource constraints or resistance to change. Careful judgment is required to identify opportunities for improvement without disrupting critical services or incurring excessive costs. The correct approach represents best professional practice because it proactively seeks to enhance the efficiency and effectiveness of the VMware Cloud Foundation deployment. By establishing clear metrics and a structured feedback loop, it fosters a culture of continuous improvement, which is essential for maintaining a secure, performant, and cost-effective cloud environment. This aligns with the principles of operational excellence and responsible cloud management, ensuring the deployment remains aligned with business objectives and industry standards. An incorrect approach that focuses solely on reactive problem-solving without a systematic review of underlying processes fails to address the root causes of inefficiencies. This can lead to recurring issues, increased operational overhead, and a degradation of service quality over time, potentially violating implicit service level agreements and leading to increased risk. Another incorrect approach that prioritizes immediate cost reduction over process optimization can lead to technical debt and hinder future scalability and innovation. While cost management is important, neglecting the underlying processes that drive efficiency can result in higher long-term operational expenses and a less resilient infrastructure. This can be seen as a failure in due diligence and strategic planning. A third incorrect approach that involves implementing changes without proper validation or rollback plans introduces significant risk to the production environment. Unforeseen consequences can lead to service disruption, data loss, and security vulnerabilities, which are unacceptable in a professional deployment. This demonstrates a lack of adherence to change management best practices and a disregard for operational stability. The professional reasoning framework for such situations involves a cyclical process. Assess current state, identify areas for improvement based on defined objectives and metrics, plan and implement changes with rigorous testing and rollback strategies, monitor performance and gather feedback, and then iterate. This ensures that optimizations are data-driven, risk-managed, and aligned with the overall goals of the VMware Cloud Foundation deployment. Question 15. Process analysis reveals that the vCenter server within a VMware Cloud Foundation deployment has become unresponsive, impacting multiple critical services. The immediate cause is not apparent, and the operational team is under pressure to restore functionality swiftly. Which of the following actions represents the most professionally sound and compliant approach to address this incident? Option A. Initiate a direct, manual restart of the vCenter server process without consulting any documentation or performing preliminary checks, aiming for the quickest possible resolution. Option B. Implement a complex, unapproved workaround by manually modifying underlying SC host configurations to attempt to force vCenter server back online. Option C. Delay any intervention, assuming the issue will self-resolve, and monitor the situation passively without active troubleshooting. Option D. Immediately consult and follow the established VMware Cloud Foundation operational runbook for vCenter server outages, performing initial diagnostics and adhering to documented recovery procedures before considering any manual interventions. Correct answer is D. Immediately consult and follow the established VMware Cloud Foundation operational runbook for vCenter server outages, performing initial diagnostics and adhering to documented recovery procedures before considering any manual interventions. Explanation. Scenario analysis. This scenario presents a common challenge in cloud deployments where a critical component, the vCenter server, experiences an unexpected outage. The professional challenge lies in balancing the urgency of restoring service with the need to adhere to established operational procedures and security best practices, especially within a regulated environment. The potential impact on business operations, data integrity, and compliance mandates a structured and informed decision-making process. The absence of a clear, immediate root cause adds complexity, requiring a methodical approach to troubleshooting and remediation rather than a reactive, potentially harmful quick fix. Correct approach analysis. The correct approach emphasizes adherence to the established VMware Cloud Foundation operational runbooks and incident management procedures. This aligns with best professional practice by ensuring that all actions taken are documented, repeatable, and have been pre-approved through a risk assessment process. Following the runbook for vCenter server outages, which likely includes steps for initial diagnostics, potential automated recovery mechanisms, and escalation protocols, minimizes the risk of introducing further instability or security vulnerabilities. This methodical approach is crucial for maintaining the integrity of the VCF environment and ensuring compliance with any relevant operational or security mandates that govern the deployment. It prioritizes a controlled restoration of service over a hasty, potentially damaging, intervention. Incorrect approach is analysis. Attempting a direct, manual restart of the vCenter server without consulting the runbook or performing initial diagnostics is a significant regulatory and ethical failure. This bypasses documented procedures designed to prevent unintended consequences, such as data corruption or security breaches. It represents a failure to follow established operational controls and could violate compliance requirements related to change management and incident response. Implementing a complex, unapproved workaround, such as manually manipulating underlying infrastructure components or attempting to restore from an untested backup, is also professionally unacceptable. This action demonstrates a disregard for the established VCF architecture and its operational guidelines. It introduces significant risk, as such actions are not validated and could lead to data loss, system instability, or security vulnerabilities, all of which would be considered regulatory and ethical breaches. Ignoring the incident and hoping it resolves itself is a dereliction of professional duty. It fails to meet the basic requirements of incident management and service restoration, potentially leading to prolonged downtime and significant business impact. This passive approach is a clear violation of operational responsibilities and any service-level agreements, SLAs, in place. Professional reasoning. Professionals facing such incidents should employ a structured decision-making framework that prioritizes adherence to documented procedures, risk assessment, and clear communication. This framework involves 1. Incident identification and triage, recognizing the severity and impact of the outage. 2. Procedure adherence, immediately consulting and following the relevant operational runbooks and incident response plans. 3. Diagnostic steps, executing predefined diagnostic steps to gather information about the root cause. 4. Risk assessment, evaluating the potential risks and benefits of any proposed remediation actions. 5. Controlled remediation, implementing approved solutions in a controlled manner with appropriate change management processes. 6. Verification and documentation, thoroughly testing the resolution and documenting all actions taken. 7. Escalation, promptly escalating the incident if it cannot be resolved within defined parameters or if it requires specialized expertise. This systematic approach ensures that actions are taken in a responsible, compliant, and effective manner, minimizing risk and maximizing the likelihood of a successful service restoration. Question 16. System analysis indicates that a VMware Cloud Foundation deployment is being planned for an organization operating under strict data sovereignty and audit trail regulations. Which of the following deployment strategies best aligns with these jurisdictional requirements and professional best practices for regulated environments? Option A. Conduct a comprehensive pre-deployment assessment of all applicable data sovereignty and audit trail regulations, mapping each requirement to specific VCF architectural components and operational procedures, and design the deployment to meet these requirements proactively. Option B. Rely on third-party compliance checklists that broadly cover cloud deployments, without performing a specific analysis of how these general recommendations apply to the unique regulatory landscape governing the organization's operations. Option C. Prioritize the fastest possible deployment to gain immediate operational benefits, with a plan to retroactively implement necessary security and compliance controls as resources become available, deferring detailed regulatory review until after the system is live. Option D. Implement a standard VCF deployment with minimal customization, assuming that default security settings will satisfy regulatory needs, and address any compliance gaps identified during post-deployment audits. The correct answer is D. Implement a standard VCF deployment with minimal customization, assuming that default security settings will satisfy regulatory needs, and address any compliance gaps identified during post-deployment audits. Explanation: Scenario analysis. Deploying VMware Cloud Foundation (VCF) in a regulated environment presents significant challenges due to the stringent requirements for data integrity, security, and operational continuity. The need to integrate a new cloud platform with existing, often legacy, infrastructure while adhering to specific compliance mandates, e.g., data residency, audit trails, access controls, requires meticulous planning and execution. Missteps can lead to regulatory noncompliance, data breaches, service disruptions, and reputational damage. The challenge lies in balancing the agility and scalability benefits of VCF with the absolute necessity of meeting all applicable regulatory obligations without compromise. Correct approach analysis. The correct approach involves a comprehensive, risk-based assessment of the regulatory landscape and its direct impact on VCF deployment architecture and operational procedures. This means proactively identifying all relevant regulations, e.g., data protection laws, industry-specific compliance frameworks, and mapping them to specific VCF components and functionalities. Best professional practice dictates prioritizing configurations and controls that demonstrably meet these requirements from the outset. This includes implementing robust identity and access management, encryption for data at rest and in transit, comprehensive logging and auditing capabilities, and network segmentation, all aligned with the specific mandates. This approach ensures that compliance is embedded into the design, rather than being an afterthought, thereby minimizing the risk of future remediation and associated costs. It reflects a commitment to due diligence and responsible deployment. Incorrect approach is analysis, an approach that prioritizes rapid deployment and feature enablement without a thorough regulatory impact assessment is professionally unacceptable. This failure constitutes a direct violation of the principle of due diligence, as it neglects to identify and mitigate potential compliance risks. Specifically, it can lead to the deployment of systems that do not meet data residency requirements, lack adequate audit trails for regulatory scrutiny, or have insufficient access controls, thereby exposing sensitive data and the organization to significant legal and financial penalties. Another incorrect approach is to assume that standard VCF configurations inherently satisfy all regulatory requirements. This assumption is flawed because regulatory landscapes are diverse and often highly specific. Relying on generic best practices without validating them against the precise mandates of the relevant jurisdiction is a form of negligence. This can result in noncompliance with critical aspects such as data sovereignty, specific encryption standards, or reporting obligations, leading to severe regulatory sanctions. Finally, deferring compliance validation to post-deployment phases or relying solely on external audits without proactive internal controls is also professionally unsound. This reactive stance increases the likelihood of discovering critical compliance gaps late in the process, necessitating costly and disruptive rework. It demonstrates a lack of foresight and a failure to integrate compliance into the core deployment strategy, which is a fundamental ethical and professional failing in regulated environments. Professional reasoning. Professionals tasked with VCF deployments in regulated environments must adopt a proactive, risk-aware, and compliance-first mindset. The decision-making process should begin with a deep understanding of the applicable regulatory framework. This involves engaging with legal and compliance teams early and often. The next step is to translate these regulatory requirements into specific technical controls and architectural decisions within the VCF deployment. A thorough risk assessment should be conducted to identify potential compliance gaps and develop mitigation strategies. Documentation is paramount. All decisions, configurations, and validation steps must be meticulously recorded to demonstrate adherence to regulations. Continuous monitoring and periodic reassessment of compliance posture are also essential to adapt to evolving regulatory landscapes and system changes. This structured approach ensures that the deployment not only meets technical objectives, but also satisfies all legal and ethical obligations. Question 17. Compliance review shows that the proposed VMware Cloud Foundation deployment timeline is aggressive, with significant pressure to go live within a compressed timeframe. The deployment specialist is considering skipping a detailed impact assessment to meet the deadline, believing that any issues can be addressed reactively. Which approach best aligns with professional responsibility and regulatory adherence in this scenario? Option A. Conduct a comprehensive impact assessment, engaging relevant stakeholders to identify potential risks and dependencies, and develop a mitigation plan before proceeding with the deployment, even if it requires adjusting the timeline. Option B. Delegate the impact assessment to a junior team member with minimal oversight to expedite the process, prioritizing the deployment deadline. Option C. Perform a high-level impact assessment focusing only on the core technical components of the VCF deployment, assuming that broader organizational impacts will be minimal. Option D. Proceed with the deployment as scheduled, relying on vendor documentation to identify potential impacts and address any issues that arise post-deployment through reactive troubleshooting. The correct answer is A. Conduct a comprehensive impact assessment, engaging relevant stakeholders to identify potential risks and dependencies, and develop a mitigation plan before proceeding with the deployment, even if it requires adjusting the timeline. Explanation. Scenario analysis. The scenario presents a common challenge in IT deployments, balancing the need for rapid deployment with thorough impact assessment. The pressure to deliver a VMware Cloud Foundation (VCF) environment quickly can lead to shortcuts in evaluating potential consequences. This is professionally challenging because a rushed or incomplete impact assessment can result in unforeseen operational disruptions, security vulnerabilities, or compliance breaches, all of which can have significant financial and reputational repercussions for the organization. The specialist must navigate these competing demands, ensuring that the deployment process is both efficient and responsible. Correct approach analysis. The correct approach involves a systematic and comprehensive impact assessment that considers all relevant aspects of the proposed VCF deployment. This includes evaluating the potential effects on existing infrastructure, applications, data, security posture, and operational procedures. It also necessitates engaging with stakeholders across different departments, e.g., IT operations, security, application owners, to gather diverse perspectives and identify potential conflicts or dependencies. This proactive and holistic approach aligns with best practices for IT service management and risk management, ensuring that potential issues are identified and mitigated before they manifest as problems during or after deployment. Adherence to established IT governance frameworks, which often mandate such assessments, is also a key consideration. Incorrect approach is analysis. One incorrect approach is to prioritize speed of deployment over a detailed impact assessment, assuming that any issues will be minor and easily resolved post-deployment. This is professionally unacceptable because it demonstrates a disregard for risk management principles and can lead to significant operational downtime, data loss, or security incidents. It fails to uphold the duty of care expected of a specialist to ensure a stable and secure environment. Another incorrect approach is to conduct a superficial assessment that only considers the immediate technical aspects of the VCF deployment, neglecting the broader organizational and business implications. This is ethically problematic as it overlooks potential impacts on end users, business processes, and compliance requirements. It can lead to the deployment of a technically sound solution that is operationally disruptive or non-compliant, failing to meet the overall objectives of the deployment. A third incorrect approach is to rely solely on vendor documentation for impact assessment without performing an independent evaluation tailored to the specific organizational context. While vendor documentation is valuable, it may not account for unique environmental factors, custom configurations, or specific organizational policies. This can lead to overlooking critical dependencies or incompatibilities, resulting in unforeseen issues. Professional reasoning. Professionals should adopt a structured decision-making process that begins with clearly defining the scope and objectives of the VCF deployment. This should be followed by a comprehensive impact assessment that systematically identifies potential risks and benefits across technical, operational, security, and business domains. Stakeholder engagement is crucial throughout this process to ensure all relevant perspectives are considered. Based on the assessment, a risk mitigation plan should be developed and approved before proceeding with the deployment. Continuous monitoring and reassessment during and after deployment are also essential to adapt to changing circumstances and ensure ongoing success. This methodical approach ensures that deployments are not only technically successful, but also align with organizational goals and regulatory requirements. Question 18. The evaluation methodology shows that a comprehensive impact assessment for a VMware Cloud Foundation deployment must consider a wide range of factors. Which of the following approaches best aligns with professional best practices and regulatory considerations for such an assessment? Option A. An assessment driven by vendor recommendations for hardware and software configurations, prioritizing the adoption of the latest features. Option B. A rapid assessment focused primarily on the speed of deployment and the immediate availability of new features, with post-deployment adjustments as needed. Option C. A detailed technical assessment of VCF component compatibility and performance benchmarks, with a secondary review of potential cost savings. Option D. A holistic evaluation encompassing technical feasibility, operational readiness, security posture, compliance requirements, and financial implications, with stakeholder engagement throughout. The correct answer is C. A detailed technical assessment of VCF component compatibility and performance benchmarks, with a secondary review of potential cost savings. Explanation. Scenario analysis. Deploying VMware Cloud Foundation, VCF, involves integrating multiple complex components and services, each with its own dependencies and potential impact on existing IT infrastructure and business operation. A critical challenge in VCF deployment is accurately assessing the potential impact of this integration on the current operational environment, including performance, security, availability, and cost. Failure to conduct a thorough impact assessment can lead to unforeseen disruptions, security vulnerabilities, performance degradation, and budget overruns, all of which have significant implications for business continuity and compliance. The professional challenge lies in balancing the benefits of VCF with the risks of disruption and ensuring that all stakeholders are aware of and have agreed upon the potential consequences. Correct approach analysis. The correct approach involves a comprehensive, multifaceted impact assessment that considers technical, operational, security, and financial implications. This includes analyzing how VCF will affect existing applications, networks, storage, and security policies. It also requires evaluating the operational changes needed for management, monitoring, and support, as well as the security posture of the new environment. From a regulatory and compliance perspective, this approach ensures that the deployment adheres to any relevant VMware licensing terms, data residency requirements, and industry-specific regulations that might be impacted by a new cloud infrastructure. This thoroughness demonstrates due diligence and a commitment to responsible deployment, aligning with best practices for IT infrastructure changes. Incorrect approach is analysis, focusing solely on the technical benefits of VCF without considering operational readiness or security implications, represents a significant regulatory and ethical failure. This narrow focus ignores potential compliance risks related to data protection and access controls, which are paramount in any IT deployment. Prioritizing cost savings above all else, without a commensurate assessment of performance, security, or operational stability, can lead to a deployment that is non-compliant with service-level agreements, SLAs, or regulatory mandates for availability and data integrity. Neglecting to involve key stakeholders, such as security teams or application owners, in the impact assessment process is an ethical lapse that can result in overlooked risks and a failure to meet diverse business needs, potentially violating internal governance policies and external compliance requirements. Professional reasoning. Professionals should adopt a structured, risk-based approach to impact assessment. This involves identifying all potential impacts across technical, operational, security, and financial domains. Engaging all relevant stakeholders early in the process is crucial for gathering comprehensive input and ensuring buy-in. The assessment should be documented thoroughly, outlining identified risks, proposed mitigation strategies, and contingency plans. This documentation serves as a critical artifact for decision-making, regulatory audits, and ongoing management of the VCF environment. Professionals must prioritize adherence to VMware's licensing and support guidelines, as well as any applicable industry or governmental regulations, ensuring that the deployment is both technically sound and compliant. Question 19. Market research demonstrates that organizations in regulated industries are increasingly adopting hybrid cloud solutions. When deploying VMware Cloud Foundation, VCF, for such an organization, which risk assessment approach best ensures adherence to industry-specific compliance mandates and regulatory frameworks? Option A. A risk assessment that focuses primarily on optimizing VCF performance and scalability to meet business operational demands. Option B. A risk assessment that prioritizes identifying and mitigating potential VCF deployment risks based on their direct impact on specific regulatory requirements and compliance objectives. Option C. A risk assessment that adopts a reactive stance, addressing compliance concerns only when they are identified during post-deployment audits. Option D. A risk assessment that emphasizes identifying the most cost-effective VCF configuration options, even if they introduce minor compliance uncertainties. The correct answer is B. A risk assessment that prioritizes identifying and mitigating potential VCF deployment risks based on their direct impact on specific regulatory requirements and compliance objectives. Explanation. Scenario analysis. Deploying VMware Cloud Foundation, VCF, in a regulated industry, such as financial services or healthcare, presents significant challenges due to stringent compliance requirements. Organizations must demonstrate that their cloud infrastructure meets specific security, data privacy, and operational integrity standards mandated by governing bodies. The challenge lies in balancing the agility and cost-efficiency benefits of VCF with the non-negotiable need for regulatory adherence. A misstep in risk assessment can lead to non-compliance, hefty fines, reputational damage, and operational disruption. The VCF deployment specialist must proactively identify, analyze, and mitigate risks that could impact compliance posture throughout the deployment lifecycle. Correct approach analysis. The correct approach involves a comprehensive risk assessment that directly maps potential VCF deployment risks to specific regulatory requirements. This means identifying threats and vulnerabilities within the VCF architecture and its operational environment, evaluating their potential impact on compliance objectives, e.g., data confidentiality, integrity, availability, and then prioritizing mitigation strategies based on the severity of the risk and its regulatory implications. This proactive, compliance-driven risk management ensures that the VCF deployment not only functions technically, but also meets all legal and regulatory obligations from the outset. This aligns with the principle of security and compliance by design, which is a cornerstone of responsible technology deployment in regulated sectors. Incorrect approaches analysis. Focusing solely on technical performance metrics without considering regulatory impact is a significant failure. This approach overlooks the fundamental requirement to operate within legal frameworks, leading to potential breaches of data privacy laws, security standards, or operational mandates. Such a failure can result in severe penalties and loss of trust. Prioritizing cost reduction above all other factors, including security and compliance, is another critical failure. While cost-effectiveness is important, it cannot supersede regulatory obligations. Deploying VCF in a manner that compromises compliance to save money is a direct violation of regulatory principles and exposes the organization to substantial legal and financial risks. Adopting a wait-and-see approach to compliance, addressing issues only when they arise or are flagged by auditors, is also professionally unacceptable. This reactive stance demonstrates a lack of due diligence and a disregard for the proactive measures required by regulatory frameworks. It significantly increases the likelihood of noncompliance and the associated negative consequences. Professional reasoning. Professionals tasked with VCF deployments in regulated environments must adopt a risk management framework that is intrinsically linked to compliance objectives. The decision-making process should begin with a thorough understanding of the applicable regulatory landscape. This understanding should then inform the identification of potential risks associated with the VCF deployment, including technical, operational, and security risks. Each identified risk must be assessed for its potential impact on compliance. Mitigation strategies should be developed and prioritized based on their effectiveness in reducing risk to an acceptable level, with a clear emphasis on meeting regulatory requirements. Continuous monitoring and reassessment of risks throughout the deployment and operational phases are crucial to maintain compliance. Question 20. Assessment of the most effective and compliant method for establishing network segmentation and security policies within a newly deployed VMware Cloud Foundation environment, considering the need for consistent application across all deployed workloads. Option A. Implement network configurations solely through direct interaction with the NSXT Manager API, independent of VCF's workload domain deployment process. Option B. Utilize the VMware Cloud Foundation API or SDDC Manager UI to define and deploy network segments and security policies as part of the workload domain configuration. Option C. Manually configure network segments and firewall rules directly on individual XC hosts and vCenter server instances. Option D. Rely on ad hoc, unversioned scripting to configure network segments and security policies across the VCF infrastructure. The correct answer is B. Utilize the VMware Cloud Foundation API or SDDC Manager UI to define and deploy network segments and security policies as part of the workload domain configuration. Explanation. Scenario analysis. This scenario presents a common implementation challenge in VMware Cloud Foundation (VCF) deployments, ensuring consistent and secure network configurations across a distributed environment. The professional challenge lies in balancing the need for rapid deployment with the imperative of adhering to security best practices and potential regulatory compliance requirements. Even if not explicitly stated for this exam's scope, the underlying principles of secure deployment are universal. Misconfigurations can lead to security vulnerabilities, operational instability, and increased troubleshooting time, impacting the overall success of the VCF deployment. The pressure to deliver a functional environment quickly can tempt teams to bypass or simplify critical steps, making a structured and compliant approach essential. Correct approach analysis. The correct approach involves leveraging VCF's built-in automation and configuration management capabilities, specifically through the use of workload domains and their associated network configurations. This method ensures that network policies, such as NSXT segment configurations, firewall rules, and routing, are defined and applied consistently across the VCF infrastructure. By utilizing the VCF API or SDDC Manager UI for initial deployment and subsequent modifications, administrators adhere to the intended operational model of VCF. This promotes repeatability, reduces manual errors, and aligns with the principle of infrastructure as code, which is a cornerstone of modern cloud deployments. This approach inherently supports security by ensuring that network controls are applied uniformly from the outset, minimizing the attack surface. Incorrect approach is analysis. Manually configuring network segments and firewall rules directly on individual XC hosts or vCenter server without going through VCF's orchestration mechanisms is a significant failure. This bypasses the centralized management and automation provided by VCF and NSXT, leading to inconsistencies, potential security gaps, and a lack of auditability. It violates the principle of managing the VCF environment as a unified system. Implementing network configurations solely through direct interaction with the NSXT Manager API without integrating these configurations into the VCF workload domain deployment or lifecycle management process, also problematic. While the NSXT API is powerful, using it in isolation from VCF's intended workflow means that these configurations might not be managed, updated, or rolled back consistently with the rest of the VCF infrastructure. This can lead to drift and make troubleshooting complex VCF-related network issues more difficult. Relying on ad hoc scripting for network configuration without a clear version control or integration into the VCF deployment pipeline introduces significant risks. Such scripts are prone to errors, difficult to maintain, and lack the inherent validation and consistency checks that VCF's managed workflows provide. This approach undermines the automation and standardization goals of VCF and increases the likelihood of misconfigurations. Professional reasoning. Professionals should approach VCF network implementation by first understanding the VCF architecture and its intended operational model. This involves prioritizing the use of VCF's native tools and APIs for deployment and management. When faced with implementation challenges, the decision-making process should involve 1. Consulting VCF documentation and best practices for network deployment. 2. Identifying the appropriate VCF constructs, e.g., workload domains, NSXT integration for the task. 3. Utilizing the SDDC Manager UI or VCF API for configuration and deployment. 4. Implementing network security policies as part of the workload domain definition. 5. Ensuring that any custom scripting or automation is integrated into the VCF lifecycle management process and subject to rigorous testing and version control. This systematic approach ensures that the deployment is secure, consistent, and manageable throughout its lifecycle.